Hello guys, welcome back to the next lecture of learning advanced DSA in Python. In the last lecture, we saw about a linked list, what is a node, right? What is a linked list, what are the types of linked list, and how do we create a node class and your create linked list, right? All these things we have seen in the previous video. But guys, those who have not watched previous video, first watch that and then come to this video, right? And in this video, we will see all the operations, all the possible operations which are there in singly linked list. Remember, in the last video, I told you we have two other types of linked list called as doubly and your circular linked list, right? So we will see about both of them in the upcoming videos, but in this video, we will talk about all the operations we can do on singly linked list. But before that, what we are going to do is this video is completely hands-on. In this, we will write all the codes pertaining to all the operations. Okay. So first we will create our node class. Then we will create singly linked list, right? How we do create a linked list, right? This we will see. And then we will traverse, insert at beginning, insert at end, insert at position. All these are very important programs. Then delete beginning, delete end, how to search an element in linked list if it is present, how to update an element in the linked list if it is present, and then finally how to reverse. Right. Let's talk about how we create a node. Okay. Let me just quickly go to my pie chart and let me just simply create a node, create node, right? So let me just create a node class. So what I will do, class, I will write node. No confusion in this. Then what I do, I create one constructor. And what is this constructor? What is this class and all? You guys have to revise my oops lectures. So please go and revise and then it will be more clear. Right. So what I will do, I will do data to data. Sorry, data to data. And then finally I will do next as none because initially my node will have none. Right. Then this is my node class. This is how I create my node class. But is the memory allocated now? No. Memory will not be allocated till the time I will not create any object of the node class, right? And that node class object will have this data and the next. Initially, next will point to none, right? And this we have seen in the last video as well. So what I will do, I will simply create head first. Now I'm this is done. Node class is done. Now I'm creating linked list. Linked list. So what is the very first node, guys? What is the very first node? Say suppose I want to create. Let me go to this. I want to create four nodes. I want to create these four nodes. Okay, and these four elements: 10, 20, 30, 40. Right? And we know every node, this, they will have its own dynamic memory allocation, right? They will not be contiguous like arrays. So we already know this. And the second, this part of the node represents the address. And this node one, it will point to the node two, right? Node two, it will point to node three. This, it will contain address of node three. This will contain address of node 4, so it will point to node 4. This will contain my none because my last node does not point to anyone in singly linked list. Now, who will point to this node, guys? Who will point to this node? Head will point to this node, right? And this is how I create my singly linked list. So what I will do, I have created this node class. So to create my head, I will create object of node class. I will pass the data as 10 and I will store it in head variable, right? So this head variable now is storing the address of the node which is containing 10 and head will start pointing to this. Correct. Now head dot data, if I will print head dot data will be what? 10. Correct? Because this is data. This is data, right? And head is pointing to this node. So head dot data will be 10. Head dot next. What will be head dot next? Head dot next should contain address of this node. Correct? So what I can do, I can simply write head dot next It will contain address of node 20. So can I not write like this, guys, to create my single linked list? And this we have already seen in the last class. Correct. So head dot next, say suppose its address is, let me write 100. So 100 will come here. 100 is the address of this node, and 100 will come here, and it will start pointing to this. Correct. And 20 will come here. Now, if I write head dot next is what? This node, right? This node. And again, if I do dot next, so iska matlab, I am pointing to now this location, this head dot next, and it will contain address of what? Node 3. Say suppose node 3 is having 200, so it will have 200. So can I not write head dot next equal to node 30? Simple. So this is how I will create my singly linked list. And then finally, I will write head dot next, which is my second node, dot next, which is my third node, dot next, right? Head dot next. Head dot next is this, dot next is this, dot next is this. This should point to what? Head dot next is this. Head dot next is this. Head dot next. This will be head dot next. Head dot next is node 1. Head dot next is node 2. Head dot next is node 3. So I will write it to node 40 so that this will start pointing to, say, suppose address 300. So it will start pointing to this. This will be my singly linked list, and this is how I create, and it will be none because it is not pointing to anyone, right? So this is how I will create singly linked list. Let me just go and write the code for it. How? So I will create first object of the node class, node 10. This is my node first. Node dot next, which is my node 1. It will contain address of node 2. Head dot next. It is my node 2. It will contain address of node 3. And then finally, head dot next, which is my node 3. Node 3 will contain address of my node 4. This is how I have created my singly linked list. Easy peasy, guys. Easy peasy. Now, next operation. We are done with this. Let me mark it as green. We are done with this. We are done with this. Now it's time to perform the next set of operations, that is traverse. Traverse. Okay. So how I will traverse this list? Let's see. How I will traverse this list, guys. This is my singly linked list. I will traverse and I will print. Okay, this is my singly linked list. And here is my head. Head is pointing to this. It is having 10. It is having 20. It is having 30. It is having 40. And none. Right? So I need to iterate to this singly linked list till I reach none. So guys, what I need to do, I need to traverse this singly linked list starting from the first node till the last node, and I need to traverse till the point I reach none, right? I reach none. So what I will do, I will simply create one variable and I will assign the address of node 1. So it will also start pointing to this. And I need to print all the elements till this current is pointing to none. And when this current will point to none, when it will reach here, because it is pointing to none, so current will start pointing to none. So I will write while current is not none, right? Simply because I need to go to the last element, right? Till the last element, because I need to print 40 as well. If I do current dot next is not none, then it will print till 30. Why? Because current dot next here, when it current will come here, so current dot next will become none, so it will not be printed. So I need to consider till here. That's why I'm writing while current is not none. And simply I will just print current dot data, current dot data, and I will keep on appending current to current dot next. For example, how it will work internally, current is pointing to here, it is not none, no, so 10 will be printed, and current will start pointing to current dot next. What is current dot next? Current dot next is pointing to here, so current will start pointing to now this. And then this is also not done, 20 will be printed. Then after this, it will start pointing to 30. It is also not none. 30 will be printed. Then also it will start going to this. Then also this current is not none here because current dot next will be none. So current is still not none. 40 will be printed. And then when I will assign current equal to current dot next here, current will be now none because when it will print 40, so current will be now none. Then it will come again here. Current is not none. This will become false and then nothing will be printed. So all the four elements will be printed. Okay, so let me just go to my PyCharm and write the code to traverse singly linked list. So I will create one function called as traverse and I will name it as traverse LL. L stands for linked list. And what it will receive the head node, the very first node, right? Because head is pointing to what? My first node. And if I'm passing head to this function as input, it means what? It contains address of first node. So I can start iterating from the first node onwards, right? So what I will do, I will simply create one variable and I will assign my head to it. And now simple as we discussed earlier, while current is not none, right? I want to iterate or traverse every element, right? Till my current is not none, right? I showed you here, right? And current will be none when 40 will be printed and then current will be assigned as current dot next. So current dot next when I will be here at 40, it will be none. So current will be equal to none. So in next iteration, this will become false, which is what we want. So when current is not none, right? What I need to do, I need to just print, guys, current dot data, right? Because I need to print data and my node has data and next itself. And then after printing the data, I need to just for example, I printed 10, then I need to make current point to 20. So I will assign my current equal to current dot next. That's it. So let me just call this function traverse LL and pass my head. Right? Head is nothing but containing the address of first node. Now let me run this. This is my current file. Let me run this 10, 20, 30, 40. Perfect. But can we beautify it, guys? Can we beautify it or can we make this code or this singly linked list bit more attractive in the output? Yes, we can. What I can do, I will just add that I want is instead of a new line character, because by default print as a new line character. So I will add end as a space. So all the elements will be space separated, right? See, now I want to add something like this in the output, right? Something like this. See, currently I have 10, 20, 30, 40 in the output, right? What I want to add just 1111 arrow, something like this. 10, 20, 30, 40. So I need to add three arrows, right? So after printing 10, I will add arrow. After printing 20, I will add arrow. And after printing 30, I will add arrow. But after printing 40, guys, I will not add arrow. So till what point I need to add arrow? Till my current dot next is not none, right? Why? Because I will reach till this. So this dot next will be none. So after 40, I no need to print arrow. So what I can write simple after this and before incrementing the value of current or before changing the value of current, I can simply write if current dot next is not none. Simple. What I need to print? I need to print one arrow. That's it. And I want to just end it with space. Simple. A new line character. Now let me just run this code. Perfect. See, now I have a very good representation of singly linked list. And this is a code to traverse your singly linked list. Now, I am done with traversing my singly linked list. So creating node is done. Creating my this is done. Singly linked list and traversing singly linked list is also done. Now next I have is insert at beginning. Insert at beginning is very easy, guys. A two-line code. For example, say suppose 10, 20, 30, 40. 10, 20, 30, 40. I have this linked list, right? Currently 10 is pointing to 20, 20 is pointing to 30, 30 is pointing to 40, and so on. And head is here, the first node, right? Now, what I need to do, I need to simply create a node and point to this. That's it. Point to head. Simple, right? If new node, if new node dot next starts pointing to where head is pointing, right? Or starts pointing to head like this, then I will be able to add one new node in the beginning. Correct. It's so simple. It's so simple. You will see the code and you will yourself understand it. Right. So this is insert at beginning. Insert at beginning. Let me just write the code def insert and let me just name the function as insert beginning. And I will have my head and any other argument I will get in this function, right? Yes. What? The data. Because this new node, right? This new node should have some data. Let's say 5. So I will pass 5 and then I will call my node class with 5 so that it will create one new node. So I need to pass this 5. So I can name this 5 as X. Here X is nothing but the data of the new node. Data of the new node. So new node will be my node class of X. Simple, right? And in this new node dot next, in this, what will happen? What will happen after this point, guys? Say suppose if X is 5, I will get a new node like this 5, and currently this is none. But shall I keep it none? No, I need to point where my head is pointing, that is to my first node. Then only it will be inserted to the beginning. So what I can do, simple. I can run new node dot next equal to head and then I can return new node. Simple. Very simple code, one or two liner code, right? That's it. That's it. Now let me call this insert at beginning. Insert at beginning and I will pass this head and I will pass, say suppose I am passing 5, right? And then it will return new node. Then it will return my new node. Let me capture it in a variable and let me run this. See, this is the output of this traverse LL. So let me just comment, right? Let me just comment. No, I don't see any output. Why? Because I have not printed the list. Now to print the list, can I call this function with the new node, the node which I have added? Yes, I can, because my new node is pointing to the first uh, element. So let me just call traverse LL to new node. Yes, this 5 got inserted, which I wanted at the beginning. Now I have 5, 10, 20, 30, 40. And before calling it, before inserting at beginning, what was my list? Let's see. 10, 20, 30, 40. This was my list before, singly linked list. Now I have 5, 10, 20, 30, 40. You will say readability is less. So let me do one thing. Let me do one thing, guys. Let me just add a blank print statement so that the next outputs will be printed at the new line. Okay. Now let me run this. See, this is the original list. Now I have inserted at the beginning. And this is the very, very, very easy. I created a new node and my head started pointing to the new node. That's it. So simple. Insert at beginning is done. Right. So this operation is also done. Let me come here. This is also done. 4 operations done. Now I need to insert at end. Very, very important concept from the interview standpoint, right? One of the companies, top companies asked me this, right? So, firstly, what I will do, I will simply create a new node, right? What I will do, I will simply create a new node and I will pass, say, suppose X. And X can be my any element, right? Any data, 5, 10, 20, 30, 40, 50, any data. So, I will create new node. Now, I need to insert at end. What if my singly linked list is blank? I don't have any node. So I will check one condition. If my head is none, if my head is none, then what I need to do? I need to simply return this node. Why? Because this node is the only node to insert, right? At the end, because there is no end. So this will be the only node which will be there. That is only a single node got inserted at the end. So this is the very first condition I will check. Now, if it is not none, if it is not none, what I will do, I will just simply create one variable and I will assign my head to it. Got it? Like it's just simple. Now, Let's see the linked list representation for now. 10, 20, 30, and then let me create one here. So here I have 10, it is pointing to this, 20, it is pointing to 30, it is pointing to 40. Now I need to insert at end, and here it is none. So what I need to do simply, here it is pointing none, right? It is pointing to none. What I need to do is I need to simply make it point to the new node which I created, 50, and it will have none. That's it. Instead of none here, I will make it point to the new node. I will make it point to the new node. So what I can do, while current dot next is not none, because I need to reach till here. I need to reach till here. While current dot next is not none, so I will just keep on incrementing or increasing my current dot next. I will keep on going. For example, I am at 10. Current dot next is not done, so I will move to here. It is not done, I will move to here. It is not done. Current dot next, so it will come here and then it will check it is none. So what I will do, I will just simply make as current dot next point to new node. Simple, so simple. And then I will return my head. Simple, right? This is how I insert at end. Let me just write the code for it. It's a very simple code again, but yet very important. Insert at end. Okay. So I will create one function, insert at end. Uh, End, and I will receive head and X as usual. I will create one new node. I will create one new node and I can call my node class with the value X. So uh, my new node got created. So what I will do? First, I will do my initial checks. If head is not none, sorry, not none. If head is none, if I don't have any element at all, what I will do? I will simply return my new node. So simple. So simple. If not, then I will make head point to my current. And this we have already discussed. While current dot next is not none. If it is not none, just keep on doing current equal to current dot next. And finally, in current dot next, make it point to the new node and then return your head. Simple. This will insert your new node at the end. Let's call it insert at end. This, it will return this head. Let me capture it and let me call my traverse linked list with the head. Let me run this, guys. Okay. Sorry. I am not passing any value. Say, suppose I want to insert 50, right? Because insert at end is expecting X, which is my data for my node class, right? So now let me run this. Here my 50 got inserted at the end. Okay. This was the insertion at very beginning. 5, 10, 20, 30, 40. This is my insertion at the very end. Now, shall we do one more? Shall we do one more? Do you want me to do insert at a specified position? Let's do it. Otherwise, you can take it as a assignment also, but I don't want. I will give some assignment for doubly linked list and circular linked list. But let me just cover insert at position as well. Insert at a particular position. So we have inserted at the beginning. We have inserted at the end. So say suppose I have this linked list, singly linked list, right? Now I want to insert, say, suppose at particular position. Say, suppose I want to insert a new node here. So this needs to point here and this needs to point here. This is how insert at position works. Okay. So simple, right? I can just write a code for it. You will easily understand because now you know insert at beginning, insert at end. So let me just create insert at position. Okay. So let me just create one function, insert position, and simply I will expect here three arguments. One is head, that is the reference of the very first node. Second is the data element of the new node, and then the position itself, at which position I need to insert, right? After this, I will again, as always, I will create a new node with the node class and I will pass X into that and that. Now I need to check, this position can be anything. This can be beginning, this can be end, and this can be in the middle. So what I can check, if position is 0. Right? I will check it at right. If position is 0, it means what? I need to insert at beginning. Agree with me or not? Agree with me or not? And this we have already done. See, and this we have already done insert at beginning. Just make new node dot next point to head. That's it. That's it. That's it. Right? So what I will do, I will simply write one condition if pos or position equal to 0, new node dot and next make it point to head. Simple. And I will simply return my new node because my position is 0 and this new node got inserted at the position 0. Right? We will test it out as well. Else, I will do current make point to head, and then here I will start my loop and I will go to my position minus 1th index. Now see what? If I need to insert here, so I will have to start from here, and I need to stop here, right? I need to stop here. So what I can do, I can start a loop for I in range until which point I can go. I need to go. Say suppose I want to insert a third position. So I need to go till my second, right? So I need to go till pause minus 1. So it will come 3 minus 1, 2. So it will run 2 times for 0 and 1. So I will come till here. Agree with me or not? Let me explain again. So if it is my linked list, 3 elements. Now if I need to insert at the third position here, right? So I need to run my loop 2 times. First here and then here, and then I will stop here, and then I will make it point to the new node, and this will point to this, right? So I will start one for loop, guys. I will start one for loop for I in range, and I will do pause minus 1. That is position minus 1. What I will do, I will just simply do current equal to current dot next because I just need to start current, right? Now I need to change 2 pointers. I need to change 2 pointers. Current dot next need to point to new node dot next, right? This current dot next needs to point to new node dot next here, right? And then new node will point to my current dot next. These two are the pointers I will change, right? Agree with me or not? Again, like it's very easy, but I'm taking some time so that you guys don't have any confusion. I have a new node here. Okay. Currently, say suppose it is containing address of this 300. So 300 is assigned to this. And here I have this node address as 400. Right. So I need to point this first to 400. That is new node dot next. Right. So current dot next will be my new node dot next. New node dot next. Simple, right? And now my current dot next, which is my this, its value, which is 300. I need to store in the new node so that it starts pointing to this. So what I need to do, and my new node will be my current dot next. Simple. Simple, right? Current dot next, this will point to this, and a new node this will point to current dot next. Simple, right? Let me just change the pointers, change 2 pointers. New node dot next, the new node which I have created, it will point to where my second element is pointing, and then finally the new node will point to where the current element is pointing. Simple, and then finally I will return my head. It's done. It's done. I guess it's time to test. I think we have written the correct code. If it is at the 0 position, it's 0. And then if it is at the end or in the middle, it will handle this. Right? Let me just call insert at insert position. I'll pass head. And I want to insert, say, suppose 75. I want to insert at position 2. Right? It will return my head, and then I will call again traverse LL with head so that it gets printed. Let's see. Perfect. See, 75 got inserted at the second position, right? Here, this is my original list. Here I added this at the beginning, and then I inserted this at the end. And then finally 75 got inserted at the end. Here you see 50 because I have used 50 as well. This also got called. But if I will just comment it, you will not see the output. So let me keep it as is. So, but you see the gist, right? 75 got inserted at the end. Now let me keep at position as 0. Let's see if it gets inserted at the beginning. Where yes, 75 got inserted at the beginning. Let me keep it as 1. 75 got inserted at 1. Let me keep it as 6. 70, it will throw error because there is no such position. If I do 5, then fifth is the last position, right? So that's why it got inserted. Let me make it as 2 again. So insert at position is also done. Easy peasy, guys. Easy peasy, but yet most asked interview question. So this is also done. Now we have two simple programs. Two simple programs, right? I want to give it as an assignment, but again, I just don't want to do anything. So I don't want to leave anything in the single linked list because it is very important. So let's do delete beginning and delete end. Delete beginning and delete end. I will explain both parallelly, right? So that you understand what is the delete beginning. Delete beginning is like this, like this. Here I have my head, the first node. It is pointing to second node. It is pointing to my third node. What I need to do? What I need to do, guys? I need to simply return from head dot next. That's it. Can I not simply return head dot next? And head dot next is what? Head dot next is address of my second node. So can I not return simply this? Return head dot next, and I can add one extra check that if head is none, return none. Okay. Let's see. Let's see. Let me just traverse done. Insert at beginning. Insert at this. Now it's time to delete beginning. Delete beginning, and I will just create one function. Delete beginning, and I will pass it as a head. If head is none, this is my edge case. I can still check. If head is none, that is my single linked list is empty, then I will return none, right? No point of deleting anything, right? Else I will just simply return head dot next. Simple, very easy peasy, right? From the second element, it will start printing, right? See, let's see, delete beginning. I will pass head, and then finally I will store it as a head, and then I will call traverse ll, and I will pass head. Let's see, guys. Yes, see, 10 got deleted, right? See the output, the last output. This is the output of my traverse. This is the output of my insert at beginning. This is the output of insert at end. This is the output of insert at position. This is output of delete beginning. So this is done, right? Now do delete end. If I want to delete from the end, let's see the code of it, right? Let me just write very simple code. Delete end, I will pass just head. Now let's see the code. Firstly, if single linked list is empty, I will return my none, right? Or if there is only one element, or if there is only one element, right? Or if there is one element, how I can check if head dot next is none, return none, because that only element will be deleted. If either the list is empty, okay, why added two check? See, in this condition, if my single linked list is empty, I don't have any node, so just simply return none. Or if I have the head is the only node, so how it will look like 5, and here I will have none, because this is my only element in my single linked list. So I can do head dot next is none, so return none, because this will be deleted, so return none. So that both the edge cases I have handled. Now I need to delete from the end, so I will start my loop while cur dot next, because I need to delete the last element. Okay, so let's say I have four element. I have four element. One, two, three, four. Okay, let's see. Here it is 200. It is pointing to this. Here it is 300. It is pointing to this. And here I have 400. It is pointing to this. Here I have none. Because last is always none. So I need to delete this. I need to delete this. So why I'm saying while current dot next is not a none. हमको इस पॉइंट तक क्यों जाना है? Why we need to go till this point? Let's understand. Let's understand. I am here. Current dot next will be 200. Dot next will be 300. Is it none? No. So what I will do, I will simply do current equal to current dot next. Right? Simple. We have seen. So it will come here. Current dot next is 300. Dot next is 400. Is not none. No, it's not none. So what I will do, I will simply move here. Current dot next is 400. Dot next is none. Right? Is none. So this will become false. So my pointer will still be at here. My pointer will still be at here. So I can just simply make 400 point to cur dot next point to none. Simple. Then this node will be deleted, right? This node will be deleted, right? Okay, let me open my PyCharm. Is not none. Is not none, I will simply append my cur equal to cur dot next. Simple. And then cur dot next, I will set it as none. Then I will simply return my head. This would be my delete at end. Simple. Very simple code. Nothing fancy. Now let me just call delete end and I'll pass as head. Store as head. Return spelling is wrong here. So let me correct. Then I will finally not print. I need to traverse because I cannot print the head. It will just return a memory address, and we have seen it. So let's see the output. Okay, see, 50 got deleted from the end. This is the output of my traverse link list. If it is confusing, then what I can do? Okay, no, not confusing because we have already seen. See, let me explain. This is the output of traverse list. This is insert at beginning. 5 got inserted. This 50 got inserted at the end. 75 got inserted in the second position. Then 10 got deleted from the beginning. Then 50 got deleted from the end. So now I have this list with me 20, 75, 30, 40. So delete at end is also done, right? So we are done with 8 operations, guys. 8 operations, right? And all these are very, very important. And the most important is the last one, reverse one. This is very, very important. Rest is very easy peasy. Okay. Search is very easy. We need to just loop and we need to check whether cur dot data is equal to the item we are searching. We need to just return true because we have found the element. So let's write code for this search. Let's write code for this. It's very simple. Search in the linked list. So I will create one function search LL. I need to pass this head and the data which I am searching. I will just make simple as head equal to cur and I will just while cur is not none. Now here I'm not writing cur dot next. No, I'm just writing cur is not none. Why? Because I need to go till the last element. And when I can go till the last element when current element is not none, right? So I need to do current dot data equal to data. I can simply return true because the element has been found, right? And then we need to just increase the value of current, right, in the loop. And then finally, if we have not found, if it is not, if the function has not returned true, in the end, we will just simply return as false. Let's see the output. Okay. Found is data found. Let me create a variable and call search LL. I pass head and call it as 20. Let me just print is data found. Let me run this. Is data found true? Why? Because 20 is there. Let me run for 40. Let's see if it is giving me 40. 40 is true. Let me do 75. 75 will also be true. Let me do 100 or let me do 50 because 50 got deleted. Return false. It is working as expected. So search LL is also done. Search LL is also done. Now the last two programs, update or modify or reverse. That's the only two program I am left with. Update is also very, very, very easy. Very, very, very easy. Let me just create a function, update linked list. And I need to just have two more arguments. What is the old value? What is the new value? I need to update that node with. Okay. Simple. I will start cur equal to head while current is not none. I need to simply check if it is not none. Keep on checking if current dot data equal to old. Right? I need to update it. Means it I need to update. So what I need to do? I need to simply change the current dot data to the new. And then simply I need to return the updated or modified list. It's so simple. It's so simple. And if we have not reached it, so keep on appending cur equal to cur dot next. Simply. And then finally we will return head. It's so simple, right? Just keep on traversing the list till I reach none. And if I found that data is the old one, it means I need to update. I will set cur dot next equal to new, right? And then finally, I will updated ll. I will call update ll. I will call head and say suppose I need to update 75 with 750, the new value. Now let me just call traverse ll with updated ll. Let me run this. See, 75 got replaced with 750. Is it not updated? Is it not updated? It got updated. So update LL is also done. Very easy peasy again. Very easy peasy program. And now let me. Is the recording started? Yeah, recording is progress. I got scared, right? Whether the recording is happening or not. Okay. Now the last one is the reverse one. Reverse linked list. This is bit important. This is bit important. What I need to do is, say suppose this is my current scenario 27, 50, 30, 40, or 20. Current scenario of linked list is 20, 75, 30, 40. This is my input, right? And these are the nodes, of course. This is the data, this is the address, this is the data, this is the address, so and so, so and so. What I need to do is I need to do like this: 40, 30, 75, 20. The last element, which is pointing to none, will become my first, and it will start pointing to the 30 because we need to reverse it from this to this. So what I need to do? What I need to do? Here I need to maintain one more variable called as previous, and first I will assign it to none. And then I will make current equal to head. Now we'll see the significance of this previous. What is my list? 20, 75, 30, 40. These two are the variables which I will create to reverse. Very, very important, very, very important interview question. So please focus, please pay your complete attention. What I am currently here at this head, and current is also here at this, the first one. So what I will do, while current is not none, because I need to go till the end, because I need to reverse, right? So first I will need to go till end, right? So what I will do, while current is not none, so I will create one variable called as next node. Next node, right? Next node will be what? Current dot next. What will happen after this system? Current is not none, right? So next node will be current dot next. That is here. It will be like this. So next node after this iteration will be your 75. 75 wala node ka address. Right? 75 will not be stored again. Its address will be stored because in next we have the address. And then in current dot next, I will maintain previous. I need to maintain both the things, the next node and the previous node. So next node will be my this 75 and it is pointing to 30, right? So it is pointing to 30. This will be my next node and my previous node will be 20. This will be my previous. It's address. Current dot next. In next node, the address of this second node will be stored, and in previous, the address of first node will be stored. And now finally, I need to increment or I need to change the pointers. I need to make previous as current, and I need to make current as my new next node. Simple. Simple. Current will come here. Current will come here, and previous will come here, and I will keep on doing this, and finally I will return the previous, right? Let's see it in practical. Let's see in practical. It's very easy. Let me just write the code of it reverse, and it will take only one argument, that is the address of the node 1. I need to create two pointers. All right, current will be pointing to head while current is not none. Simple, right? I need to maintain two things: next node, and what will be the next node? Current dot next will be my next node, and the previous. What will be the previous? Previous will be, what will be previous? Current dot next will be my previous node. Next node will be current dot next, and previous will be my current dot. Sorry, next node will be my current dot next, right? Next node, and previous will be my current dot next. Simple. And then finally, I need to change the value of previous, and I need to change the value of next node simply, and then at the end I need to return my previous one. And now let me just see if my code is working fine. Called as reverse, it will return a list. Let me now traverse this list. Traverse ll. Perfect, the list got reversed: 40, 30, 7, 50, 20. If there is still a confusion, let me just again explain what has happened. What has happened? I have 720, 750, 30, 40. Let me take this example only. 20. And let's say address store here is 200. Okay. And its addresses, this is my next. Here I have head. And its addresses is suppose 100. So it is pointing to 75, right? Or 750. 750. And so suppose its address is 200, right? Its address is here 200. Now in this, here the next is 300, the value of the next node. So its address is 300. And let me see the value I have 30. Okay, 30 and 40. So 30 is here, and its address will be 400, the address of the next node, the last node. And finally, I will have the last node 40, and here it will be none. Simple. Okay, none. So what I am saying is I will maintain two variables. First, my previous is my none. Okay, it is my none. So previous is pointing to none currently. And I have created current just like any other code point to head. That's it. Now what I am doing, I am starting one loop and I'm saying while current is not known, while current is not known. So what I need to do here is I need to go till here one by one, one by one, one by one, one by one. Starting from here till the end, I am starting one loop because I need to reverse, right? So what I am doing, next node, see, next node. I'm creating a variable called as next node, and its point and its value will be cur dot next. Cur dot next is what? Current is currently pointing to here, where my head is pointing. Cur dot next is 200. So next node, which is my next node, it will have my 200 or the address 200 at the very beginning. And previous. This is my next node. This is my next node. And previous, what I'm saying is current dot next. Here also current dot next. Okay. And in previous, what I'm storing, previous is currently none, right? Previous is currently none. So in current dot next, because this will be my last node. Remember, this will be my last node. So in current dot next, I am storing as none. Got it or not? We have any confusion in the second line of the code? See, first line is next node equal to current dot next, and then current dot next will be none. Okay, so let me go to this. So after this, what will happen? After this, what will happen? Current dot next, here it will be none, and here I have 20 because I have done. I have assigned previous, right? And my next node is containing 200. Next node is current dot next. Current dot next. So, and current dot next, this is my new node. This is a variable just containing my 200, right? 200. So, till this point, if it is clear, then I am doing previous. Then I am assigning current to previous. What is current? What is current currently? Current is 100. Current is 100 because it is 100. So previous value will be 100. See, next node is 200. Next node is what? This. And this will be my previous. Now previous will be here. Its address is 100. And then next node is my 750, 300. This is the value of next node. And current dot next is already set to none. This is what I am doing. This is what I am doing. Right? And then there is one more step. I am assigning next node to my current. What is my next node? You yourself tell me. You yourself tell me it is 200. So my current will now point to here, the 200. 200 is here. So current will come here. So this is my previous, this is my current, and this is my next one. Now what again will happen? Current dot next is not none, right? Current is here, 300 is not none. So next node is current dot next. So now current next node will be 300. So next node will be 300. So I will have this node, right? With 300 address. So next node will come here. Its address is 300. And then current dot next will be previous. Current dot next will be previous. Previous is what? Previous is what? Previous I have changed, right? Previous is 100. So 100 is what? This. So current dot next will be my 100. Current dot next will be my 100, which is what? My not none. This will be my 100. So current dot next. What is my current dot next? This. So this will be changed to my 100. So this will not point to this. This will now point to this. So this is how reverse is happening. This is how reverse is happening. You yourself dry run this and you will understand this, right? So that's all I guess from this video. That's all from this video. This is the reverse linked list, and these are the important steps within the reverse, right? Maintaining next node, maintaining previous, maintaining current, right? You need to maintain all three. Okay. So with this, we have completed reversal as well. And we are done with all the operations of singly linked list. Congrats, guys. With this, singly linked list is complete. Now I will cover doubly and circular. And after doubly and circular, I will paste some LinkedIn questions as well. And then with this, all the things will be done and dusted with regards to with regards to linked list. And then we'll start a stack, queues, and the other things will go on. Jai Hind.